Hello and welcome to this lesson on generics. My name is Pradeep. So, in this lesson, we're going to see what generics are, why it's important to use them, and more about generic classes, generic interfaces, using wildcards, and very importantly, what generic methods are and how to use them. So, by now, as by now, in the lessons related to collections, very likely that you would have already used generics. Let's do a quick recap of that. So, what's the basic need for generics? Well, it provides compile time type safety and no need for explicit typecasts. For example, without generics, this is the kind of code that you might try to write. Let's say a list, numbers equal to new array list. We need to import them. Control Shift O will import them. Now, and then I could go on adding elements into it. So as you can see, I am not using the generic form of list and array list. I'm using the older so-called raw form of list and array list. So I'm adding numbers. So numbers dot add, I'm adding a bunch of numbers. So the point about generics is, let's say we intended to add only numbers into this list, but what if by accident I end up adding a string? So since without generics, everything is type for object, a string would also be considered an object. So therefore, this is allowed. Already you can see on the screen that our compiler is complaining that you're using the raw type list and it's not really recommended to use that. It says list is a raw type, array list is a raw type. Primarily what it's saying is you should be using generics. Let's see. Another problem that this generic solves, other than this accidental addition of wrong type of element into collections, is the problem of typecasting. Let's say I wanted to retrieve the element back from this list. So I'm going to do integer I1 equals numbers dot get of 0. Right? The first element happens to be an integer, but the compiler complains that it's a type mismatch. Cannot convert from object to integer because get method is designed to return an object when you use it without the generic form. So we are forced to add a typecast to integer. We are forced to add a typecast to integer. So this is quite annoying to keep on typecasting the elements back to their original type when you retrieve an element from inside a collection. And needless to say, again, the problem of wrong typecasting also exists. For example, let's say I want to do integer I3 equals typecast to integer of numbers dot get of 2. So we know that this third element at index 2 is not really an integer, it's a string, but the compiler is allowing me to typecast it to integer. So this can lead to runtime class cast exceptions. This can lead to a runtime class cast exception. So this is the problem of not using the generic types and relying on object data type when it comes to working with collections. Such heterogeneous collections are rather rare, and only when you really have a need for such heterogeneous collections. By heterogeneous collection, what I mean is one element is an integer, another element is a string, another element is a float, and so on. Those are very, very rare. So only then you should use these raw types. Otherwise, you shouldn't really be using them. So what should I do to solve this? Well, this is the reason why all these collection interfaces and classes have been made as generic types, which means they accept a type parameter. Since I'm planning on adding only integers into this collection, I should really use angular bracket integer and declare this variable to be of type list angular bracket integer, which we say or which we read as list of integer, equals new array list of integer. Array list of integer. So once we create this to be of type list of integer, you see straight away that when you try to accidentally add a wrong type of element, which is not an integer, you get a compile time error. So this code does not compile. And secondly, you need not really typecast this to integer type. So the return type of get method is automatically considered integer. Therefore, using this generic type provides for compile time type safety and no need for typecasting the elements when you retrieve the elements from the collection. This is the main reason why we make use of generic types. So this integer that we are passing within angular bracket to list as well as to this array list is called a formal type parameter. This is called a formal type parameter. So interfaces and classes which accept type parameters are called generic interfaces and generic classes. So if we look at the definition of this list, you would see that this list interface has been declared with a formal type parameter, that it's an interface which takes a type parameter e as an argument. This e isn't really any keyword or anything. By convention, we use one uppercase letter. And since lists contain elements, to indicate element type, we have used e. That is all. Similarly, if you now look at the definition of the add method, so you would see that add method doesn't now take argument of type object, but add method takes an argument of type e. So which means if you create list of integer on a variable, on that variable when you call add method, it takes integer. E is integer in that object or in that variable or in that reference. So similarly, if you now take a look at the get method, which takes an integer as an argument, so you would see that the return type of get method isn't an object, instead it is e. So in our code, e is integer, so which means get returns integer, add takes integer. So this is the basic use of generics.